by our restaurant, or they might be 2 miles of our restaurant. They might be having transit problems. Maybe there's a backup in traffic and they're not going to get to where they needed to be. Is it raining? Maybe they like to stop in. Do they have kids? We have a great opening at 7 o'clock, for a special on kids meals, and we're a family-friendly restaurant. Maybe we should let that person know that as they're walking by our restaurant. And maybe we should give them movie tickets for afterwards because we know they like this kind of movie, and the movie theater's 2 blocks away. That's how you now have to think about an application. And every app we now build, every app has to have that kind of context about a person, or else it's going to be left behind very quickly. And that's why I say transformative apps.
Even toys. Toy Talk is a new company. They just got $16 million. It was started by the ex-CTO of Pixar. And the toy itself, the iPad, is going to know what the weather is. And they're going to make an API call out to weather.com or something and know that it's raining outside, and they're going to change the behavior of that toy. Even toys are changing because of this
Absolutely.
Stuff. So what does this mean to real business? Mattel thinks of themselves as real business, but most of us are studying, I don't know, oil field results or sales from a retail store or something like that.
Exactly, and we do see it everywhere. We see these problems, and these problems kind of manifest themselves around one of the biggest pain points where we play with our technology is this notion of continuous availability. We have become a very spoiled culture, and we have become a very demanding culture. Think about your own experiences. If you go to get on a site or an app and you have to wait 2 seconds, you get frustrated. You start to bail. You start to look for other alternatives. So this idea of an app being continuously available is a paradigm shift. This is not how we used to think before. We might have one backup server or a very small cluster. But again, now we're at country scale. Now we're at global scale. How do I ensure that that's going to be continuously available all around the world? Multiple data centers is now the norm for these architectures. So businesses have to make sure, A, that they're going to be there and available. B, it better be fast. It has to scream. So when that application is talking directly to the device or to the customer, it has to be able to operate in a way that they're not going to lose that customer loyalty very quickly, right?
Yeah.
So all those problems create this other challenge of operational simplicity and then cost. You can't let this stuff get out of control either. Every business that we work with is fighting with that, and we range from Fortune 100 businesses, we range from household names like Adobe or Netflix down to startups who are just trying to solve a brand new problem in a new way, but they have that same common use case of continuously available, extremely high performance, low operational cost to keep my overall cost down.
So Cassandra, you're built on Cassandra, and what other technologies are underneath your covers?
So what we do initially, we take Cassandra's beautiful architecture, which is something called fully distributed, which basically just means that you can access it from anywhere. Every node's the same.
Yeah.
If you lose a machine, you don't feel it. It goes on about its merry way.
So you can have 1,000 servers, and if 4 of them disappear because of a power outage or something, you don't see that, the system doesn't go down.
Continuous availability. And this is something you'll hear Netflix talk about a lot. Even though Netflix does so much in the cloud, being in a high availability zone in the cloud is not enough. They actually spread it across availability regions in the cloud to make sure if they take a hit, like with Sandy, or a power storm, or an outage of some other type, that they can still carry on, even if you lose an entire data center. So think about just not losing a couple machines. What if you lose a data center?
Yeah.
How do you avoid that disaster? That's kind of the challenges that they're looking at today.
We have customers now building on top of Amazon and Rackspace Cloud to make sure that if Amazon goes away, Rackspace is still there, or if Rackspace goes away, Amazon's still there, right?
And I highly recommend that, actually. We've got a big retailer we're working with at the moment that's got a co-located physical data center. So they've got the same database now, spread across 2 physical data centers, but then it's also spread across 2 cloud environments, and it's the same database in all of those worlds. And anybody from anywhere can hit it from any place. So if you lose one of them, it doesn't go down. So that's our first use case. Yeah. We take that great distributed architecture, then we say, you're probably also going to want to do some searching. You're probably also going to want to do some analytics. So we take 2 very popular open source technologies called Apache Solr and Apache Hadoop, and we bring those on top of the Cassandra architecture, truly integrated, not just loosely connected, truly integrated, so that line of business, when they're thinking about writing one of these transformative apps, has everything they need for their silo to build that app. Then they may take the data and they might pipe it over to their Hadoop data warehouse or something like that. But for us, we tend to live with that line of business app.
Does this work only on cloud, or can you host it internally on your own data centers?
No, absolutely internally, and that's key to what we do. We want to be agnostic to the underlying destination decision, and that's critical actually to what we do, because we don't want to limit architects in saying this is a cloud-only solution, or worse, only that cloud, which I think is the worst scenario.
Yeah.
We want to be able to say, you can spread this across your physical data centers, you can spread it across your cloud data centers, or any combination therein.
Well, Rackspace, we love that because we gifted the world OpenStack, right? That's an open source technology now, and you can run that internally, externally,
Absolutely.
on our servers, on competitor servers or whatnot, and so it gives you a lot of choice. But a lot of businesses need sometimes the control. You know, if you're a pharmaceutical company, you might not be able to host on a public cloud. You might have to host that data internally on your own.
Government agencies, we see it as well.
Same thing.
Yeah, same thing there. But you hit on it. It's the flexibility of being able to take those baby steps. For example, let's say you're a traditional business and you're starting off and you would say, I want to control it. Maybe just philosophically you can't get over it. Well, okay, fine. Start in your data center. But wouldn't it be nice if you took a couple pieces of it and started pushing it off to a cloud just to test? You can do that with our technology. That's the beauty of that fully distributed architecture, is you can take baby steps into the cloud. You can take baby steps into multiple clouds. Or you can go all in from day one if you choose to. It really doesn't matter how you go about doing it.
So Cassandra was developed partly at Facebook, and Solar was partly developed for Yahoo, right? They've had their own hardcore geeks to manage. But we're talking to a lot of businesses around the world who don't have a hardcore DBA. How geeky is this, and can I do it just without knowing too much, or what do I need to learn? Who do I need to bring on board to help me build one of these big data systems?
Yeah, great question. At essence, that's why we exist. We want to make this technology consumable and accessible by businesses, and what we say by mere mortals. Sometimes when you talk about the crowd at Google and Facebook at Yahoo, it's still eye-popping what they do. They do so much customization. They do so much of their own tweaking. They're brilliant. The average company is not in that business, so they have to find a way to consume this technology in a way that enables their teams to move very, very quickly. They don't want to get behind in the administration side of things. So what we've done as a company is bring all this stuff together and package it in a way where you can be up and running in minutes. And we have demos on, if you want to get started very quickly, we can get a cluster up on Amazon, for example, in I think it was under 3 minutes or 4 minutes to get a 10-node cluster up and running. If you want to do it on premise, you can do it on a couple of machines. If you want to virtualize it on one box,
you can do it on Rackspace Cloud.
You can do it on Rackspace Cloud. We have people doing it there as well. And we have our job is to make it easy to get up and running and get started, because one of the knocks on our technology in the early days was it's what I call 3 standard deviation guys. These are guys that are way at the end of the bell curve, and we're bringing that back into the masses because we do solve technical challenging problems. I do want to say, when people choose Cassandra, one of our customers, Meta Broadcast, we just did an interview with them, and they said, we don't choose Cassandra for simple problems. These are complex problems where we need amazing performance, so we have to balance that with ease of use. If we sat down and I said, Robert, tell me about your app you're trying to build. And we started talking about it, and I said, okay, what happens if that goes down? And you came back to me and said, well, as long as I'm up in 5 minutes, nothing really, not a big thing. Probably not in the best conversation. But if you tell me, no, that's the whole point. I don't want this thing ever to go down. My users have to know that they're going to be able to get it and get it fast when they need it. Now we're in a good conversation. As an example, big data, right?
But can't MySQL do that? Can't other database technologies?
So I'm getting to that, right? So that big data, people tend to think, if you're not immersed in it, you tend to think volume. Right? Thousands of or millions of something or other, right? In our world, sometimes we have customers who do fairly small implementations, but they got to spread it. They got to have it across data centers. They got to have some of it in the cloud. They got to have some of it in multiple clouds. That gets awfully difficult, if not impossible, with relational technology. It's why I made a career change, because I saw this modern transformative app requiring this availability in new architectural ways. Relational databases just weren't designed to handle. They just weren't. They still have their use cases. And the second part that I would answer to that is, it's not an either or. We have to get over that. So many people want to know, if you're using this, it means you're not using that. Modern architectures today, you'd be amazed how